Imagine the world inside your body as a vast, intricate network of signals, reactions, and energy flows. Every day, the foods we consume send messages to this network, shaping the way we think, move, and even age. Carbohydrates are among the most influential of these messages. They are simple in structure, yet profoundly complex in effect, providing the body with fuel, signaling hunger, and influencing hormones that govern mood, energy, and long-term health. Understanding carbohydrates is not merely a question of calories or weight, but of how the body orchestrates energy, growth, and repair on a cellular level. When you consume carbohydrates, the digestive system breaks them into simple sugars, primarily glucose, which then enters the bloodstream. This triggers the pancreas to release insulin, a hormone that acts as a key, opening doors to cells so glucose can be used for energy or stored for later use. The speed and intensity of this process depend on the type of carbohydrate. Refined sugars create rapid spikes, while complex carbohydrates release energy gradually, supporting stability and sustained performance. Beyond immediate energy, carbohydrates impact the microbiome, the trillions of microbes that inhabit the gut. Fiber-rich carbohydrates feed beneficial bacteria, promoting balanced inflammation, nutrient absorption, and even mental health through the gut-brain axis. Conversely, excessively refined carbs can disrupt this ecosystem, contributing to insulin resistance, chronic inflammation, and metabolic stress over time. The body's response to carbohydrates is deeply intertwined with lifestyle, activity level, and genetic predispositions. Athletes, sedentary individuals, and older adults experience glucose and insulin differently, meaning the same food can produce radically different effects depending on context. Carbohydrates also influence hormonal balance, satiety, and neurotransmitters, subtly shaping cravings, mood, and cognitive function. In this way, carbohydrates are both fuel and messenger, affecting not only how we feel in the moment, but also how our body adapts, ages, and maintains resilience. Carbohydrates provide immediate fuel through glucose while regulating energy storage via insulin. Complex and simple carbohydrates impact blood sugar and energy differently, influencing metabolic stability. Fiber-rich carbs support gut microbiome health, influencing inflammation and nutrient absorption. The body's response to carbs varies with activity, lifestyle, and genetic factors. Carbohydrates influence hormones, satiety, and neurotransmitters, affecting mood, cognition, and long-term health. Carbohydrates are the body's most readily available source of energy, and their impact begins the moment they enter the digestive system. Once consumed, carbohydrates are broken down into simple sugars, primarily glucose, which then enters the bloodstream. Glucose serves as the primary fuel for every cell in the body, from the contracting fibers of skeletal muscles to the neurons firing in the brain. Its presence in the blood is immediately detected by the pancreas, which releases insulin, a hormone that acts as a key to unlock the doors of cells so that glucose can be absorbed and utilized for energy. This process is fundamental not only for daily activity, but also for sustaining life at a cellular level. Without glucose, the brain would struggle to function, muscles would tire more quickly, and even essential metabolic processes would slow down. The body's management of glucose is finely tuned. When energy is needed immediately, such as during movement or cognitive activity, glucose is shuttled into cells and metabolized to generate ATP, the universal energy currency of the body. When glucose is abundant and immediate energy demands are low, insulin directs excess glucose to be stored in the liver and muscles as glycogen, creating a reserve that can be mobilized when needed. This balance between use and storage illustrates how carbohydrates are not simply calories, they are signals that communicate with the body about when to act, when to conserve, and how to allocate resources. The type of carbohydrate consumed significantly influences this process. Simple carbohydrates, like sugars and white flour, cause rapid spikes in blood glucose, prompting a swift insulin response that can lead to fluctuations in energy and mood. Complex carbohydrates, found in whole grains, legumes, and vegetables, release glucose more gradually, providing a steady stream of energy that supports sustained physical activity and cognitive function. Over time, the way the body handles these carbohydrates have profound implications for metabolic health. Consistent consumption of balanced carbohydrates can maintain energy stability, support muscle function, and protect organ systems from the stress of glucose volatility. In essence, carbohydrates function as both fuel and regulator. They deliver immediate energy to power cells and simultaneously communicate with hormonal systems to manage energy distribution and storage. This dual role underscores why carbohydrates are central to human health, influencing not only performance and endurance, but also the body's ability to adapt, repair, and maintain balance in response to daily life demands. Their effects ripple through metabolism, activity, and even long-term disease risk, demonstrating that the simplest nutrient can have the most profound impact on how we live, move, and thrive. Not all carbohydrates are created equal, and the body responds differently depending on their complexity. Simple carbohydrates, such as refined sugars and white flour, are broken down quickly in the digestive system, producing a rapid influx of glucose into the bloodstream. This sudden spike signals the pancreas to release insulin in large amounts, prompting cells to absorb glucose at a fast rate. While it provides an immediate surge of energy, it is often short-lived, leading to fluctuations in blood sugar levels that can affect mood, focus, and sustained physical activity. Over time, repeated spikes and crashes can contribute to insulin resistance, metabolic stress, and increased risk of chronic conditions such as type 2 diabetes. Complex carbohydrates, in contrast, are composed of longer chains of sugar molecules that take more time to digest. Found in whole grains, legumes, fruits, and vegetables, these carbohydrates release glucose slowly and steadily, providing a steady stream of energy for both muscles and the brain. The gradual increase in blood sugar allows insulin to work efficiently without overwhelming the system, supporting metabolic stability and reducing the risk of sudden energy crashes. Additionally, the slower digestion process often increases satiety, helping regulate appetite and reducing the tendency to overeat. The difference in blood sugar response also has implications for long-term health. Stable glucose levels minimize stress on the cardiovascular system, improve nutrient utilization, and reduce systemic inflammation. Athletes, older adults, and sedentary individuals all experience these effects differently, but the principle remains consistent. Complex carbohydrates provide a more controlled, sustained energy supply, whereas simple carbohydrates deliver rapid but fleeting fuel. Understanding the distinction between these carbohydrate types is essential for managing energy, mood, and overall health, especially in the context of daily activity, cognitive performance, and long-term metabolic resilience. By choosing carbohydrates wisely, the body can maintain balance and function more efficiently, supporting immediate energy needs and long-term well-being. Carbohydrates provide immediate critical support for gut health, particularly through their impact on the microbiome, the vast community of microbes living in the digestive tract. Fiber-rich carbohydrates, such as those found in whole grains, legumes, fruits, and vegetables, are not fully digested in the small intestine. Instead, they reach the colon largely intact, where they become food for beneficial bacteria. These microbes ferment the fiber, producing short-chain fatty acids like butyrate, which nourish the cells lining the colon, reduce inflammation, and contribute to overall digestive health. A thriving microbiome enhances nutrient absorption, ensuring that vitamins, minerals, and other essential compounds are utilized efficiently throughout the body. Beyond digestive benefits, the gut microbiome has far-reaching effects on other systems, including the immune system and even the brain. Signals from gut bacteria influence inflammatory responses, hormonal balance, and neurotransmitter production, which in turn affect mood, energy, and cognitive function. Diets low in fiber or high in refined carbs can disrupt this delicate ecosystem, reducing microbial diversity and allowing harmful bacteria to proliferate. This imbalance can lead to chronic inflammation, impaired metabolism, and increased susceptibility to illness. Consistently consuming fiber-rich carbohydrates provides a steady supply of nutrients for beneficial microbes, promoting resilience and adaptability in the gut environment. This not only supports digestive regularity, but also contributes to metabolic health, as a healthy microbiome improves insulin sensitivity and glucose regulation. Additionally, the fermentation of fiber slows the release of glucose into the bloodstream, complementing the effects of complex carbohydrates and supporting energy stability. The relationship between carbohydrates